Hello everyone, and welcome to this presentation. I am Philippe Schmid. I'm a PhD student in the low-Q research group at INRIA, and I'm going to talk about the project we did with Andy Cockburn, Sylvain Malacria, and Mathieu Nancel about what we call interaction interferences. You may have already experienced situations where you're about to perform an action, like clicking an unread email, and at the very last moment, the interface changes. It fetches new mail, for example, but you still end up clicking on what is now a different email, because even though you may have noticed the change, you couldn't refrain from performing that planned click. This phenomenon can be found in other situations, for instance when a pop-up window appears right before you click on a link, covering it and thus catching the click. We call these phenomena interaction interferences. They're changes in the interface that occur right before a user performs a physical action and too late for them to interrupt it. This happens because events are interpreted in the context of the current system state, regardless of how recent it is. Changing the state even 1 millisecond before receiving the click, and still interpreting the event as being issued in the context of this new state, is totally fine for the system. Yet it is highly unlikely that this was the user's intention. Both the computers and us users need time to process information. We thus need to take this reality into account. We first set out to qualify this family of issues, so we created an online survey discussing examples of experienced interaction interferences, their frequency, how severe their outcome was, and how frustrating people felt about it. It came out that participants could easily find examples of such phenomena, and even though those interferences are generally of minor consequences, they cause trouble and are a source of annoyance and frustration. Among the most severe ones, we had portions of a password appearing in plain text after another window took focus, texting the wrong contact, or calling someone by mistake. Our next step was to start characterizing this phenomenon by estimating the minimum reaction time to inhibit one's action in a common context. Most of our participants' examples were related to pointing and clicking, so we focused on this task. There exists related work on that topic in neuroscience and SIGCHI, measuring, for instance, the minimum delay under which a user can't refrain from starting a pointing motion or from typing a key. However, in the context of virtual target acquisition, interference issues do not result from moving the cursor, but from clicking at the end of that movement. And that distinction has not been previously studied in SIGCHI. We adapted an experimental protocol from neuroscience to a virtual pointing task. Participants were asked to click a green target as fast as possible. However, in a random 15% of trials, the target became red shortly after it appeared, in which case the participants were instructed to refrain from clicking. In those so-called stop trials, we needed to control the delay between that red stop signal and the time of the click. So we had to estimate the moment where the click would happen. The specifics of this process are described in details in the paper. Our main results consist in a profile of successful click inhibition. They indicate that, when given 350 milliseconds to inhibit a click at the end of a pointing motion, users manage to refrain from clicking about 50% of the time. And at 600 milliseconds, we get close to 100%. An interesting fact about these success rates is that there seems to be no impact of the pointing task's difficulty in FIT's terms. So, what does that mean? Basically, input events occurring after a state change on their target can, for example, be considered interferences, say 400 milliseconds or less after the change occurred. And simply flagging these inputs as hazardous to the user might already avoid annoyance and frustration. Our next steps will involve solutions to prevent or mitigate the resulting errors. Thank you for your attention. I'll be happy to answer questions now and later by email.